This is part 5 of the Permanent Magnet Synchronous Motor Control series with Professor Duco Pule. Simulation for field-oriented control.
So here we see field-oriented control. Now the controller consists of a current controller as before. The only difference is now that the angle information comes from an encoder here. So that's the big change. Before we had open loop control. Now we have closed loop control of the angle. The angle physically is fed through an encoder. And the encoder signal comes from the simulation direct in this case. This is a simulated motor. This angle information is fed back in here into the controller. So we need to orientate ourselves. We can do either speed control or we can do current control or closed loop control. So we'll do this with just current control right now, and that's probably the most easiest. And we're going to observe, of all things, this vector. Now the d-axis is automatically set in the same direction as the flux. So in this case here, this is going to be, we know that the flux vector is tied up to that axis. That's what we made. This is flux. Okay? So if we see the d-axis, we know this one is tied up. If you've made up if you connect this up properly, this will be where it should be. If you have not connected that properly, and you have misconnected your encoder, this will be incorrect. But this has to be correct. Now, once we do this, we can then hit the button and run the application. We'll put both initially at 0. We'll stop it and observe what happens. Now, I've run this now, it's under current control, and nothing happens. This is a d-axis. This is the d-axis, this is the direction of flux. It's really important. Nothing happens. Now, if I apply a d-axis current, a current in the same direction as the flux, then the theory will tell you, if you put current in that direction, there will be no torque produced. And no torque means it's not going to go anywhere, it's going to stay there. So observe what happens when you put a current of 1 amp in that direction, or 1.5 amps. The current is now in that direction, no torque, nothing. Because current has to be at 90 degrees to the flux to be able to produce torque. There's no current in that direction. You have produced a heater at this stage. All you're doing is heating up the machine. It is not doing anything. So it's not going to rotate, it's just going to sit there. If you now set that current back to 0, and now observe when I look at this thing, and now I put a current in 9 degrees to the flux. Stop it quickly. You see now that we have produced a current vector, the red one, at 9 degrees to the green, where the flux is. We now have torque, physically torque. 53 million meters. We are now producing torque. The machine will start to accelerate. Yeah? Exactly as you expect it to do. If I put the current in the other direction, bang, opposite direction, this gets a little complicated, but wait till it settles down. It will now move the torque in the opposite direction and it will slow in the other direction. This gets a bit messy, but that's always the way. It'll clean up in a minute. Okay, this is the green, the flux direction. This is the current. Current's 2 amps. We are now producing a current in the negative direction, which is set by and that length of that current vector determines the torque. If I bring that current down half the value, the torque will be reduced. If I bring the current in the other direction, the torque will be positive. It will go in the opposite direction. Okay, that's what we achieve with this particular simulation. So, and that's what we can achieve now in the actual machine in exactly the same way. But this will test our controller, right? If we do speed control, all we're doing is controlling this IQ through a controller. So if I switch this on and run it again, we have speed control. So in this case, the only difference is that the IQ component is now controlled directly through speed control. No difference. and it's speed control. And there's the speed here. That's the reference speed, the actual speed here. And if I do a speed reversal, bang, it will set the current maximum and it will do a reversal in the same thing. These are the currents. And again, you can observe operation at this stage, exactly with the actual controller you're using.